All right, let's finish up here with our lab and get to the fun part. So we, in the previous video, installed and loaded the new packages we need. We imported and subset our data. So now we're going to conduct the actual PCA analysis. So we want to create a new object. We'll call it res, short for results.pca. And we'll use the PCA command from the FactoMiner package. The data we want to use to create that PCA is that subsetted data we created in the previous video. We want to scale the data. So when you're creating a PCA, you have the option of scaling it or not scaling it. In this case, we will scale our data. When you're doing a PCA, it can create different dimensions for you. So in a PCA, typically you have two axes, right? Or maybe I should be doing it this way for you. So usually this axis is PC1, this is PC2 on the bottom. So each PCA plot is two dimensions, right? So here we're plotting PCA1 and PCA2. We can also plot PCA2 and PCA3, etc., etc. So here by default, we'll ask it to keep 5 dimensions. We'll only plot the first 2 dimensions. Those are usually the most informative, but just FYI, that's what this particular argument is doing. And here we want to tell it that that first column of our data set is giving us information about the data itself, but it doesn't actually contain gene expression information. And we also want to graph the results of our PCA. So we'll use the option for the graph argument, graph equals true. So we'll execute that. May take a little while because it contains 1,500 genes. And we get this now popping up in our plots window, which is not helpful at all, right? So here we have dimension 1 on the bottom, dimension 2, this is a PCA graph of variables. It is so crowded right now because every single one of those 1,500 genes basically is written on this graph, and so they're just all layered on top of each other, and we can't read it at all. That's fine. This isn't the pretty graph, I promise you. This is just an intermediate step. So when we do want to make that pretty graph, we will use this particular function from the Facto Extra package. And yes, I am looking at my cheat sheet down here. I do not have these memorized. So we want to use that results.pca we just created. That's what we want to be plotting. For what type of plots, what type of points we want to use on our PCA, we will use points. For the colors, so how we want to differentiate the colors in our PCA, we want to color it by groups. And so to tell it that, we will say that in our original data set, we want to use the group column. That's how we want to differentiate the colors in our PCA. So that'll give us each treatment group being a different color, so it's easy to differentiate. For the color palette, here you can have a little bit of fun with this if you want. Here what you're doing is essentially telling it which color you want each of those. In this case we have 5 different treatments. You're telling it which color you want those 5 different treatments to be. So I have chosen the following colors, but again you can mess around with this and pick other colors if you want. There are tons of options. If you Google color options in R, there are lots of different palettes for you. Make sure you're putting the color in quotation marks when you're using it though. And we need one more. Okay. What else do we need? We're also on our plot going to add ellipses. So it'll plot each individual for the different groups, and we're also going to plot 95% confidence interval ellipses around each group on our PCA, so it'll be easy for us to differentiate whether the treatment groups are actually different from each other, whether they're separated out or not in that PCA space. So we will make that true. And then lastly, we want to call our legend that's indicating what the colors indicate. We will call it treatment groups. That also needs to be in quotation marks. Okay. So this is creating our pretty PCA graph. Dun, 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 dun. Here we go. Look, this is pretty, right? I was happy when I finally created this. So here, when we have our PCA down here, we have dimension 1 on the bottom. The percentages here tell you roughly what percentage of the variation in the data set is represented by each of those dimensions. So we can see dimension 1 is representing about 20% of the variation in the data set. And we can also see that dimension 1 is a dimension that separates out our different treatment groups. So if we look at our color coding here, so the lime green is the common garden, the purple is the field acclimated, the pink is field acclimated, exposed, and protected. I think maybe I forgot to mention that, but at the fields, in the field acclimated groups, there are actually 2 different intertidal sites. One of them is exposed, meaning it's much more exposed to wave splash and it's cooler. The other one is considered a protected site because it's actually right behind a big rock. And so any waves that come don't really hit the mussels down here because the rock is blocking it. So that site's warmer. In theory, but actually if we look at our PCA, those treatment groups look very similar gene expression wise. And then we also have our 2 different outplant high and low groups. So in blue, we have our outplant low group, and in red, we have our outplant high group. And so remember, when we're looking at PCAs, what we're interested in is seeing if the points, so each point's a different individual, seeing if they cluster together. In this case, because we also included the 95% confidence interval ellipses, there's also a slightly larger symbol in the middle of each ellipses that is showing the median of that particular treatment group. So here for outplant high, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 crosses that are smaller, indicating each of the 10 individuals from that treatment group. And the larger cross in the middle indicates the centroid point for that treatment group. And if we look at regions of overlap here, we see that for the most part, these 4 treatments down here are all very similar in our PCA space. A lot of those points and ellipses overlap, indicating overall the gene expression patterns are relatively similar. However, we have here that outplant high group is separated out specifically on dimension 1 from the other 4 treatment groups. So from this data set, this is telling us that the gene expression pattern of this outplant high group, which was considered the most stressful in terms of temperature and its location in the intertidal zone, we see it has a unique gene expression pattern compared to the other treatments. So you want to make sure that you save that plot. So export, save as PDF. I always recommend saving it as a PDF. We'll save it as landscape. It should default to saving in that directory that we've been using, and you can call it something like Week 8 Lab Gene Expression PCA plot or something like that. Save that, and now it'll show up in your files. You'll be able to include that in your lab report. That's what you'll need to include in your lab report. So hopefully this is satisfying for you to be able to take, if you think about it, it's really cool. You're taking the gene expression information for 1,521 genes, and that took us not a very long amount of time, right? R is able to take all the information into account for those 41 individuals, and plot this PCA for us to give us a nice overview of how the gene expression patterns of these treatment groups might be similar or different.